All right, let's get started. As usual with this class, there are a ton of announcements. This class is very complicated. So I know there's a lot of outstanding grading at the moment. So I'm trying to make sure that I'm getting feedback on the entirety of sprint one so that you know how you did, so that you can quickly change how you're approaching sprint two if needed. I don't have that for you quite yet, but I'm putting pressure on our grader to try to get that to you as soon as reasonably possible.
So you need to use peer pressure.
Yes. It's sometimes necessary. So there's that. We also have the quiz that we took. So I'm trying to get that graded and back to you in a reasonable time frame as well. On top of that, we have a client meeting on Wednesday and a sprint that's due at the end of the week. I forget if the syllabus said for some reason we were having a quiz this week, but I'm trying to space them out by at least an extra week. So nothing quiz related happening this week. I'll see exactly where we are and see if it makes sense to have a quiz next week, but it will at least be a week from Thursday. We've got another quiz in here. I think that's just about everything. Anyone with questions or concerns?
So I was really busy last week because I was dealing with aid stuff.
Yeah.
Like if I'm putting that like team chat, will you take that into account?
Yes. Yeah, it's mostly your group. The grades on an individual basis are based on how your group sees your contribution. And so if you are communicating to the best of your ability about the limitations that you have, they should not be using that against you as long as that is over the big picture leading to a reasonable contribution. If you feel like your teammates are unfairly rating you and that you are unfairly being docked for that, that will especially be apparent when you get a grade for sprint one. If the grade for sprint one is vastly different for you than it is for your group as a whole, because you will see the rubric for the sprint and then you will have a grade in Canvas. For most people in here, that is going to be one-to-one perfectly mapped. And for some people, you'll have a couple of extra points, a point or two of extra, because you ended up doing a little bit more than the average of your group, enough to separate you. And for a very few of you, it may be somewhat to significantly lower, and that would only be the case if really I've been letting you know on the side that something has been going on. And keep in mind that just because I let you know on week one, that does not mean that there's still going to be a problem in week two. For most of those, I think they've snapped back to reasonable. The reason I try to reach out and let you know is so that you can modify your expectation to match with your group's expectation. But if you still feel like you were unfairly treated from that, come talk to me, let me know, and we can have a discussion about whether there is sufficient evidence there that your group members had a point, in which case you should know exactly what happened, or if I need to make a change because you were treated unfairly, in which case we should review that and make sure that the grade represents the work that you put in. No mathematical system is going to be perfect in all cases. I've done the best that I can to create a system that is going to be best in as many cases as I possibly can, but there is still the occasional issue that I have to manually correct. If you feel like that is you, come talk to me, we can have a discussion about it. All right, so where we are going from here is we want to talk about some design patterns as the curriculum in this department changes a little bit to not require the old 212. What we're looking at moving forward, this is a meeting that we had last Friday that I can talk to people about a little bit, is that we're looking into making this class into a two-parter that allows you to kind of do what this class is doing, create your own project in 350 and introduce you to some of these ideas, and whatever the sequel to this class is going to be, then having an industry-sized project that is exactly this same project, except now blown up to 100 or 200 classes, had some design patterns fitted into it. So it looks like what you would go interface in industry. Now, can you understand and learn how to refactor large-scale code? Can you can you put a new design pattern into something that has that many possible things that can go wrong, aspects that you need to consider with regards to applying something like a design pattern to a larger scale industry-sized project? And where does AI fit into that? How much of a role can AI take if you know what you're doing with it? And when should you absolutely not touch AI augmentation to doing a system like that? Those will be the outcomes from that course. So I've been advocating for modernizing this program for a long time, and it feels like I'm finally being heard a little bit.
So I actually have a recommended use case for AI.
Yeah,
So what I typically use it for is like ambiguous bug fix. So if you're like combing memory and you cannot for the life of you find what is happening, you could basically pipe in the memory errors, be like, hey, I know it is relegated to this file, find where in the file it is.
yeah, yeah. I think it's important to have that skill set going into industry, knowing how to use AI augmentation, and more importantly than that, when to use it and when it's going to lead to more work. So that is part of the outcome of a course be designed over the next year or two to try to slot that into this system about this point in the curriculum. But before we do that, I need to do the absolute best that I can to kind of do what would be in this class and in that class and shove it into this class's project. So I apologize for what that's going to look and feel like as I try to get you the associated outcomes for all of that embedded within this scope. It's not really tested, and I don't think 212 was doing too many people too much good at that point in the curriculum. So right now, we have 10 weeks to try to get absolutely everything from 350 and what was important from 212 embedded into this in a way that gets you those skills. It's way too big of an ask for any one class's perspective. So the way that I'm going to choose to communicate that to you is that by the end of this degree, you will be expected in an industry interview to understand a lot of this material. And the unfortunate reality is that the curriculum that we have at this point is not set up to really introduce you to that in as reasonable a form as I would like. And there's a long process to go through to turn that into something that I am more okay with. In the meantime, I'm going to go over some design patterns. This is the best source that I know of for doing that, for introducing them to you. But there is way more to do than what I can reasonably do in a couple class periods of work. So my recommendation for all of you is to spend a significant amount of time on this site, thinking about how to apply these patterns, how to learn these patterns, what this code looks like so that you can go do this in a larger scale project. What we're going to be doing with this in our project is starting in the next sprint, I will be saying, apply some number of design patterns to your code. I'm not going to tell you which patterns to apply, save for one. There is one that just, it's the right call for one of the required features. I will tell you which one to apply and for what. But beyond that, there will be some additional patterns that you will need to put into your project. Which patterns you choose and where you put them will be the grade outcome. I won't tell you which ones. You will be responsible for identifying which ones go where. And I find that that kind of assignment slash outcome forces you to think critically about understanding them, not just this one goes here, apply it, great. You don't necessarily understand why or how, but if I say, in general, you pick them and figure it out, you can come to me and I can give you some guidance. But in general, in your groups, it turns into a very good discussion and research to understand and be able to apply. They're not incredibly complicated, but the actual implication of having applied one is challenging. As we talked about in last class, you can apply them in a way that makes your code just more complicated without really giving you any benefit. We looked at one such example where there was a simple program that was made way too complicated by applying every single design pattern where it doesn't fit. So you should be thinking about future scalability. And that's usually where these patterns are going to save you time. They don't really ever make anything more efficient. It's always at a time cost, so you need to be saving something in the future in order to make that time cost worth it. That extra code complexity cost worth it. There'll be right places and wrong places for that. So as we mentioned, the patterns are divided mostly into 3 large-scale categories. Here on the very left-hand side, we have creational patterns, and then there are structural patterns, and there are behavioral patterns. And so we're going to go through a fair chunk of these over the next 2 or 3 class periods, just to try to understand what are they, when would we want to use them, and in general, how do you read a site like this? Because there's no way you're going to memorize all of this over the course of the next 2 or 3 class periods. It's infeasible and honestly would be a complete and total waste of time. Ideally, from my perspective, I want to motivate their use and have you understand if there's a point in the future where you think, wow, this feels very inefficient. It feels like there was a design pattern, or there should be a design pattern that covers making this more efficient in scalability in this sense, that we should be able to plug and play one. So my hope is that I correctly allow you to make that decision in the future, to recognize where something can be improved. For those of you who have taken 212, you've seen some of these, but probably not all of them. And it's always worth reviewing them because there's a lot of value in them. So we'll start with factory because we'll just go in the order of creational patterns that we have here. So all of the creational patterns in general deal with object construction. So a lot of them are built into the object constructors or are classes that are called, instead of just having code in the constructor, you have objects that represent associated parts of the creation process or allow for optionality within that creation process. So the factory is one where if there are multiple different use cases for a similar object, we may want to construct the object in the same way, but allow for different use cases of that object. So the picture that we see here is there is a logistics factory, and within that factory, you're producing the ability to do the same thing. We want to deliver a product to a destination. We could deliver that product on the road, in which case the logistics factory needs to use the same load process to load it onto a truck, which then goes and drives off into the distance to deliver it where it needs to go. Or the sea logistics factory that is going to use that same load process to load it onto a boat, which then gets sent off via water into the distance. So similar processes, similar ideas, but slightly different results. How can we reuse code in order to be able to decide at runtime, road logistics versus sea logistics, something like that. So these are always broken down into the following sections. There's the problem, there's the solution, and then there's the associated structure, which is going to represent a UML. And you're going to start recognizing, because we've covered UML, some of these UML types of objects and relationships. So we're going to, then there's also pseudocode at the end of this. And the most important part at the end of all of the pseudocode and some question answer applicability, general how to implement, some pros and some cons, and then some code examples. So you can go click on the Java code example for this, and it will take the pseudocode from above and actually fill it with actual code. And so now you can see from that exactly how the factory would be implemented in that code. And you can download and run that code as well. So again, I see this as a very kind of all-inclusive resource for people to look at, whether you don't really understand what a particular design pattern is doing, then you read the problem and solution. If you're in the implementation, look at the steps for implementation in the UML. Look at the code once you've implemented it yourself and say, does this map to the same idea? Have I actually implemented this pattern? Does what I've implemented match reasonably the design of the code in the code implementation section? So if I am you, that's how I'm using this resource. And this is just refactoring.guru up on top. I believe, if not, then it's something that I need to reveal, that it is something that I will throw in Canvas as just a resource for people. So problem states that we're creating a logistics management app, and the first version can only handle transportation by truck. So all of our code creation lives inside of this truck class. But after our app becomes popular, the client comes back, or we decide that, hey, we can extend this to not just be a truck logistics app, but it can be an app for all sorts of different transportation needs. So when we see something like that, we will decide that we want to create and refactor this code to be scalable for different kinds of logistic, not just hard-coded for truck logistics, which makes sense if we want to handle the code logistics for all sorts of different kinds of transportation. So how do we actually do that? If we do this incorrectly, then we're going to end up duplicating a bunch of creation code between the truck class and the boat class and whatever other form of transportation we would have to extend this to. We'd be duplicating a lot of that code, and we can factor all of that out into an external object that handles the construction of that regardless of the type, in a way that allows us to more easily add in the future a plane type of cargo or a teleportation type of cargo.
So could we have forced our kind of project that we're working on in this class into this box? Because it seems like we kind of could have, but because like it would just be like CLI and GUI. And then we just
Yes.
have to,
So
sort of like would combine like the.
it fits in terms of an abstract idea of you're making two different kinds of things. The question that I would have, and the difference between implementing this or not, is how much overlap is there between the creation of these two different kinds of objects? Are you instantiating the same internal representation? So the same internal objects. Instead of doing that in two different places in your code, you could have an object with a method that constructs that and returns it as a reference to your app, either CLI or GUI. And if it's exactly the same, then you would be able to save yourself a copy and paste of code. Generally, whenever you're copying and pasting code, it's because there's something you could do to only have it in one place and refer to it from wherever you need it. But yes, so factoring may apply to something like that. And actually a question that I will be asking throughout a good few of these is, where could this apply in our project? So factory as a creational pattern may be useful if we have two different kinds of creation of a CLI kind of object and a GUI kind of object. How would that fit within this structure? So as we talk about the rest of it, I think that would be a smart way to think about the pattern, is how could we apply it to our project? So now we're replacing, the solution says, to replace the construction rather than inside of the truck class itself, inside of a factory method. So now instead of inside of, we're going to have a logistics class as a superclass and a road logistics and sea logistics, that the only thing that's different between this is the actual construction of the transport object. So the construction of the truck, the construction of the ship, the actual logic for planning a delivery is the same, whether it's on the road or on the sea. It's just that we can now do that in one place in the superclass of logistics, and we now can create transport separately. The subclasses do that, and then return it to the object that needs it. We can see, though, that as we do this, this looks kind of pointless. Move the constructor call from one part to another. But now we can override the factory method and change the class of the products being created as well. So now when we implement the deliver method, the deliver method is now based on the type of object that was constructed and not some baseline. Like, we wouldn't have to redefine all of this. We're again splitting this in a way that makes sense based on the associated objects construction. So you can imagine, as long as we have that common interface, as it says here, can pass objects through the client code without breaking it, calling whatever transport is needed in order to transport in the associated way of the object that was constructed. So we really only need one transport that figures out at runtime what type of object is this? Is this a truck object? Okay, then transport it on wheels. Is it a sea object, a boat object, then transport it over water? So it's able to figure that out from that process. So factory in this case actually looks like we have a creator, a superclass creator, some subclass concrete creators. And for those of you who haven't necessarily seen this, this is the generalization, the inheritance relationship with the open triangle here. Then we have realization between the creator and the product. So a dotted line with an arrow here. That's just saying that the creator doesn't actually, it defines what the creation is like, but it doesn't actually create anything. When we realize the creator, it becomes the product interface, which we use. The creator interface becomes the product interface, which we use to create the associated concrete products. I don't know if that was enough. Does that make sense? We have an abstracted creator that is responsible for saying, how do we create the associated products, which is able to now, because it is concrete and realized, is able to return. We just call this concrete product constructor, and it allows us to utilize it as such. Overriding the base factory method, so that it returns a different kind of product. So we can have multiple different products here. We can have a, I don't know, whatever products our shipping company would need. But note that those are irrelevant and different from how the product is shipped. It doesn't matter, you can take object A or object B, put it in the storage of a truck or the storage of a ship, and then send them off. And it doesn't matter which type they are, we just are able to now create those with the associated logistics and send them without any change in our code. It's all done at runtime. Does that make sense? Or does that make more sense? I never have a sense when I go over these kinds of design patterns at the level of which.
So the
Yeah.
concrete creator, it calls the create product, but it's gonna be different based on the interface that it uses.
Yeah,
Right, because those are concrete subclasses for each product.
yeah, so this is the constructor of some kind. So we have different constructors for different kinds of objects. And those constructors are capable of creating different kinds of products based on the associated product. But we have separation now between the construction logic and the object logic. So the important thing is that distinction. But we can now associate different concrete creators with different concrete products. So we can create sea logistics or road logistics for all the different kinds of products that we need. We don't need to specify every possible combination of all of those, because that would explode our code exponentially if we needed to define a creator for the road logistics for an apple and a creator for a road logistics for a banana. We can now say that whatever calls the banana creator, return that object to the associated logistic and throw that directly into that bin. So if the road logistics creator called the create new apple, then the apple would be placed when it's returned into the truck, etc. So we have a way of creating a boundary between that, so we don't have to specify every possible combination. We'll see that a lot in a lot of these design patterns, and a lot of it is meant to create a linear separator, maybe what do I want to call it? Not coming to me. in the way we have kind of dimensions, like an X, Y, and Z, it shaves off one of those dimensions. So instead of needing a coordinate that's based on every single one of those dimensions, we put out a dimension, put a separator here, and now say we're going to define every possible X and every possible Y and have them interact, instead of saying we need every possible XY pair. And now you have a linear amount of work instead of an exponential amount of work. So let's say X can vary between 1 and 10, Y can vary between 1 and 10. If we have all of the X over here, there are 10 objects. We have all of the Y over here, we have 10 objects, a total of 20 objects. If we need to pair them up, then we have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. We have 10 times 10 objects. And as that scales in scope, we have 2x versus x squared, which saves us one of those dimensions, going from quadratic to linear. We'll find that to be the case a lot of times, where in code we would have to handle something for every pair of something. We can handle them independently. How are we doing? If factory kind of makes sense at a baseline level, again, this is something that by itself probably deserves 2 class periods to just go over exactly how is this done. But we don't have time for that outside of having a 212 style class that goes over every single one of these patterns for most of its class. So I know that I cannot be perfect at this and get everyone all of this information. That's why there's going to be some research to do on the side. But if you get a sense of, I'm trying to create a product and I'm trying to create a logistics of some kind, and I'm finding the need to duplicate all of that, think factory pattern, and you can find a way to separate those and now create them in ways that save code. We can take it a level deeper with abstract factory, because abstract factory is kind of a factory of factories. So these are often taught in parallel, or you teach abstract factory after factory, because the way that factory works, we're creating different logistics. But now imagine that what you're creating instead of different logistics are different factories. So one dimension higher, where the separation here is for each factory type, now we need to create a factory. And if that's the case, then we want to split that up. And we can see that, again, we have 2 different dimensions. We have a family of related projects, so chairs, sofas, and coffee tables, variants of that family. So they're available in the modern, Victorian, and Art Deco variants. And so now we have 2 different dimensions associated with that. But we would like to be able to create and offload as much of the, how much, if we know that we're creating a Victorian piece, what does that entail? If we know we're creating a sofa, what does that entail? How can we split that by that associated dimension, but still have a factory when we get down into each one of those dimensions? Because a sofa factory is just one of these aspects. A Victorian factory is going to be a row. So when we end up splitting this, we end up with still a factory. So abstract factory just says that we can create interfaces for each of these types. So we would have a chair interface, and then we would be able to create beneath that a Victorian chair or a modern chair, as you would expect. But then when we see the associated object that we get down to that, there's its own factory. So that would interface with a furniture factory and a Victorian furniture factory and a modern furniture factory in ways that when we create that, it's based on what we specified within this relation. So the abstract factory abstracts all of this and doesn't care which factory it's designing for. It just knows how to handle, when you tell me which factory, I know how to give you the associated object.
Fast track.
I know, it's wild how fast I have to go through this. I don't like it at all, but it's important to know. And I also think that it gives people a good backing for doing the research for being able to apply this to your project. So we see with abstract factory, this breaks down into concrete factories. It's the interface for the associated concrete factories. The client communicates now with the abstract factory, which has the associated logic to be able to take the client's request, create the associated factory object, take the request from the client, feed that through the associated concrete factory, get back the object the client wants, and pass that back to the client, all without the client ever having to specify more than needed. So it's a factory of factories, where each of the logistics from the last factory are entire factories. Use that if you have a multi-dimensional factory problem. Luckily to me, abstract factory is one of the harder ones to think about. Factory in general is not too bad. Abstract factory starts getting fun. General questions on factory or abstract factory, just in kind of a what they are.
So it does the same thing as the factory with an extra step because you're just abstracting a new
Yeah.
factory each time, but you
Yep.
still go through everything.
Yeah, so when you have families of objects that need their own factory, it's the factory of the selection between the families of classes.
Oh, so it's kind of like an Amazon warehouse, for example, where they have one facility that makes all the Amazon Basics batteries.
Yeah,
And all the other kinds of batteries they sell would all be processed in that factory.
right.
And then say like chairs that you were building would be in another factory, but because they're both associated with the Amazon warehouse, they're like sub interfaces, kind of like levels.
Okay, yeah, I can see where you're coming from. So it'd be something like if we had the logistics problem of the warehouse, maybe there are some local orders and some other orders that need to be shipped in some capacity where the loading is the same between those. But now you would have families of objects of the Amazon batteries and the other batteries, maybe they're different sizes, and so those have to be accounted for in some other dimension. Then you would have the ability to take a client request for a battery, interpret that into which battery they're looking for, then take that, load it onto the associated factory to ship it to them.
So TLDR, an interface made up of sub interfaces.
Yes.
Good, I just wanted to make sure I was getting that.
They are concrete factories, but those concrete factories are the ability to produce any of those objects that that factory could produce based on the abstractions of those products. So yeah, this would be the abstract product, would be like the battery, the concrete product would be the Amazon battery or the name brand battery.
Kirkland batteries.
Yeah, and then you'd have different factories for handling how those products are distributed. And then the client just has to go through and place the order, and all of the work for that happens on the back end.
When you read this, does it start at the right side? Like the client uses the abstract factory interface, but then the arrows go into that. So I was trying to like follow it like a flow chart.
Yeah,
I think that's where I'm getting messed
The
up.
abstract factory is the center of everything. It handles the request and then is going to be responsible for putting together the results of that query. So it's going to call the associated concrete factory that it needs, which produces the concrete product under the abstract product, returning it to the abstract factory to return it to the client. Got it. Yeah. All right, onwards. It's just gonna be rapid fire. Caffeine over the next couple of days will do you well.
Why, Chris? Why?
My recommendation as well is to, if you have a laptop up or a tablet up or something else of the sort, be following along and just kind of, you can, if I scroll past something faster than you're reading, you can decide to read at your own pace, try to understand, map what's on the page to what I'm saying, ask a good question. So Builder is one of my favorite patterns, actually. It's incredibly useful for things like delaying the full construction of an object to later, whenever you have to do something step by step. And some of those steps are possible now. Some of those steps may rely on future user data as they contribute something that helps to specify the associated object. So the way that they state with this is that there's a house, but there are also houses with particular add-ons. So there's a house with a garage add-on, a house with a fancy statues add-on, swimming pool add-on, and garden add-on. Of course, when you construct the house, you don't necessarily know what the eventual buyer of that house is going to want. Which of these amenities are they going to want with their house? So how could we specify the constructor of this house to just construct the house and wait to eventually construct the garage, the statues, the swimming pool, or the garden, depending on the information that we get from the client at some point? Otherwise, you have to guess and have 5 different houses constructed. And when the user says, I want that object, then the other 4 are completely and totally wasted. So you could also imagine making a single constructor for each of the different types. And then you'd be reusing all of the house construction code. When you build a house with garage, you start by building the house, and then you move on to, when you build the house with swimming pool, you start with the house, and then you move on to, you'd be duplicating all of that code across all of these different constructors. And again, whenever you find yourself copying and pasting code, that is a bad thing. Wouldn't it be better if we could just, at construction time, make the house and then have associated constructor add-on methods that take in an existing house and add a garage to it? Then we wouldn't have to reuse the house construction code. The other way that this shows up nastily in code is that the constructor has a bunch of parameters in it. We have to figure out, does this house come with a garage? Does this house come with a swimming pool? Does this house come with a garden? So we need all of those parameters in the constructor itself. And so we end up, even though we only want a house with one add-on, needing to provide parameter values for every possible add-on. And that's not ideal either. And another thing that can be saved by waiting and constructing this afterwards is that the house still only needs the house constructor. We don't need all of the add-on as parameters to that. We could just call the associated method add garage to house afterwards to finish constructing the object at that point. So the solution to this is that inside of a house builder object, the constructor to the house builder constructs the house. But at the end of that, we can also add on a garage. We can also add on a garden. We can also add on something else. So the associated constructor of the object does everything that we know for sure has to happen, and then everything else is optional in terms of the methods that that builder object can construct. So again, a lot of the design patterns that we're going to see involve downsides to object-oriented code, and the fact that a constructor has to be called when the object is constructed. If you don't know all of the information for construction, when you need to construct the object, then we don't have a solution for that. There's no easy fix with directly embedded in OOP. The way to do it is the builder pattern, where you now make the construction its own object and call that object, which when its constructor is done, returns you the base object. But you can also pass it back in to add any of those extra amenities.
So it gets called as like its own method?
It's its own class. When you construct a house builder object, it returns a house and then exists for the ability to add amenities to that object
So
as needed.
is it kind of like a predefined blueprint?
Yeah, kind of.
Like similar to an interface, but it actually has stuff defined as like attributes. For example, like an interface wouldn't really necessarily define build walls, build doors, build windows, build roof. It would just say
Yeah,
house calls this, whereas this is like an interface, but it actually implements.
kind of, yeah.
So with this kind of, structure, kind of construction class, would it be more like a static kind of thing? Where,
Interesting. It ends up needing a director in between that client and builder. So the client is responsible for instantiating the director. Think of this as like the person who is there to help you construct the object.
Like a foreman.
Yeah. So I used this in 212 in the airline project because I found that this was an incredibly useful design pattern to have in that instance. So for those of you who didn't take it, the airline project, it's a ticketing system and ticket creation so that a client could say, I want tickets for myself and my 2 children to fly from location A to location B. I want to sit next to each other on that plane and etc. And the builder for this is going to, maybe you don't get all of the information from the user at a time, but you can start by constructing the ticket objects and the associated order from that information. And as they start entering their information, then you can start filling out those aspects of those tickets, like what name gets printed on the ticket. We're not ready to print the ticket when the order is started, but we can start the process of reserving the seats. We can start the process of, it's a big scheduling nightmare to figure out what can be done at different points of time in that associated process. So the director was responsible for communicating with the client and then communicating with the builder, all right, augment this existing ticket with this new information that we just got. So that had all the associated logic to do that behind the scenes, so that all the client had to do was enter information and get prompted. The director figured out what information do I need next in order to further construct this object. Since I need this information, I'll ask the client. When I get that information from the client, I'll call the builder and augment the existing associated tickets for child number 1. I'll pull up child number 1's ticket and I will add this information to child number 1's ticket. And now that that's done, that information has been updated. And once we have all the information from the user, we're ready to reserve the seats, print the tickets, return them in an associated nice order, and then it is done. We see that the concrete builder has the ability to reset objects, the associated different steps of building, has the ability to create the associated product, and once the product is created, then it is returned. But you don't get that product until the building is complete. It's like you can't move into a house with just the house without amenities. It has to be fully customized and finalized because you need to purchase those amenities. You need to have paid for the associated house. You can't say something like, build me the first floor and not the second floor and charge me. It needs to, the construction needs to be completed before you buy the house. That makes sense. So builder is super useful. Here's an example of it. We have 2 different construction objects. We construct the car and the car manual. Those are very different objects. The car can be driven, the car manual cannot. You can put gas in a car. You cannot put gas in a car manual, at least very effectively. But if you're learning how to drive the car or operate the car, it is much more efficient to operate through the car manual than the car builder. So, and also things like set GPS for the manual will tell you how to do that, whereas in the car itself, it will actually set the GPS. So you have kind of one-to-one methods between the manual, whose job it is to tell you how to do it, and the car, whose job it is to actually do it. So the director will go through the builder that is required to build both the car object and the manual for the car from the specifications that are received from the client. You can imagine that instead of purchasing a car, you are constructing the car of your dreams. Like, how many seats does the car of your dreams have? Is it a 2-seater or a 4-seater? As you specify that, then the director will add that both to the car object in terms of constructing those seats, and the car manual in terms of the associated language of how to use every single feature in the car based on the fact that there are only 2 or 4 seats in that car.
The director and controller from NBC kind of similar.
Kind of. It takes information from the user the same way that the controller recognizes that something has changed and then directs the associated changes in an underlying object. And that's very useful because in general, the client doesn't want to know how any of the internal of this works. In 212, I often say something like, as you're learning how to drive a car, do you need to know how the pistons work? Do you need to know how fuel is burned? All you need to know is this pedal go, this pedal stop. It's a much abstracted system compared to the actual underlying chemistry and physics of what's going on with the associated system. So the more we can abstract that, the better we are doing at creating a usable system that does something complicated where the interface is something that is simple. It's very similar with code. So from the client's perspective, the builder should just be taking in requests, but the director will parse the request and figure out, based on this request, here are all the associated builder tasks. Builder, go do that. Because otherwise, if the client needs to interface with the builder directly, then the client needs to know how to call the builder and all of the associated builder components. So the director is there just to abstract away the complexity of the builder so that the client only needs to interface with the commands for the director. Director can parse those commands and interface with the builder. Whenever you see client in something like this, it's an end user. And we always want the end user to be thinking about the fewest things possible. Our code should handle as much of the internal logic as possible. So I want to get into and identify the next one with just a few minutes. I probably should, or we can do singleton because singleton is faster. Singleton is the easy design pattern. It's what most people attach themselves to when they think of an easy design pattern to implement. The entire purpose of a singleton is to make sure that only one instance of an object is around at a time. And then whenever we refer to an instance of that object, it refers to that one global object. So something like you can imagine in this class, if there were 4 professors, you would have to consider something like, which professor do I email about something? A singleton would just say, there's only one professor. When you send an email to any professor, it goes to the professor.
Like a data structure, like you use it like in our program, like saying I only have one hash map.
Yes.
Exactly one, and then that you
Yes.
can build a singleton.
And if any way a second hash map were to be created, it would just duplicate the first
and
one.
reference that.
And
first
yeah, it duplicates the reference and then have a single object for now just referring to the one object that exists, even though it has 2 different names. They would have to refer to the same object.
Got it.
Yeah. So there ends up being a bit of a issue with this, but we won't quite go into that. What I'll do is I'll just upload all of my slides from 212 as well, so that people can look over what I have historically taught. The slides that are up there but not revealed now are kind of I don't really like those slides very much. They're kind of reused from, it's an information dump, very much like this, and not at a deeper level. So I want to give people resources that are a little bit of a deeper level. But yeah, the structure of a singleton is very simple. The client just interacts with the singleton. If the singleton tries to create a new instance of a singleton, it'll create a new reference to the same object, but not duplicate. You cannot duplicate the object, and it has the associated permissions in there to make sure that that is impossible. So it's pretty straightforward. We'll come back to this tomorrow and go over a good few more of these with the goal of hopefully understanding why they exist and when to use them.
Side question for you.
Yeah.
You're doing the video game course design.
Yes.
What are
Yeah.
So are we gonna be able to use design patterns like these? And I know like panels more.
Yeah,
that's like
you
this.
can utilize them. So let me.
Longer.